So, hello everybody. This chapter is about a very basic chapter of physics, units and dimension. And this one is a very easy chapter, I would say, but a very useful one, as you can say. So, we had started our physics journey. So, units. For that, I need to first explain you the physical quantities. So physical quantities, what we actually learn in physics, are the physical quantities. And what do you mean by that? It is meant by the quantities which you can measure, like the mass you can measure, like the time you can measure. So in physics, we in our daily life, in our physics, in sciences, we study those quantities. We don't study like things like patriotism or love. In abstract quantities, we don't study. We study physical quantities. Okay, so physical quantities, I can further divide them into two parts. Okay, like basics and derived one. Basics and the one derived one. Basic, I would say, like mass, time, and the derived one, which are actually being taken from the basic one. I'll explain them. It's not a big thing. So let's talk over this. If I say basic physical quantities, so it's like mass and time, which are fundamental, which does not depend on any other physical quantity. If I talk of the derived one, so if I say like force is actually dependent over the mass and the acceleration. If you remember the formula of force, so it is dependent on the mass and the acceleration as well. In fact, acceleration is also a derived physical quantity. So these comes under derived physical quantities. This is just a definition, it's not so important. So we'll just jump into the units. So if I talk of units, so to jump directly into units, let's discuss how do you need to represent physical quantity in real. So physical quantity, if I'm talking about, okay, so if I'm saying that you need to represent some physical quantity, so how you're going to proceed? Say for example, if I say there is a physical quantity like sugar, there is a physical thing, sugar, so I need to measure it. So if I say just like 5, sugar is 5, so does that make any sense? No, 5 can be anything, na? So if you are going to a shopkeeper and say just give me 5 sugar, it doesn't make any sense. So here you are considering the weight, mass of the sugar. So you need a you have 5, which is the magnitude, of course, which is the magnitude. The mathematical number is the magnitude. And the second thing is unit. Say if I say, so the unit of mass is kg. So the second thing is the unit, and both of them are important. Second is important. So I cannot say just like kg, give me kg sugar, okay, give me this I travel kilometer. No, so this doesn't even make sense. See, if I only use unit, I travel kilometer, so I need to give a magnitude as well. I traveled 10 kilometer. So these two things together make sense, or makes a physical quantity, a representation of a physical quantity. One is the magnitude, another is the unit. Okay, so I had somehow give you a brief intro about the types of the physical quantity, and so as their units type. If I say there are 7 fundamental physical quantity or basic physical quantity, you have heard it before in your previous classes as well, like time, mass, length, temperature, electric current, amount of substance, luminous intensity. So their units are called basic units. Like for time it is second, Okay, there are other as well, but the standard units are there. This R is also unit, day is also unit, minute is also the unit. Okay, length, basic unit is meter. Okay, I'm just giving the representation. And mass unit is, standard unit is, SI unit is kg. So I can also say that, we also say that these are the basic units. Okay, there is another one is temperature is also the one basic physical quantity, and the unit is of temperature is Kelvin, as standard unit is Kelvin. And there is electric current, for that is ampere. Okay, so and so, and then electric current is there as well. There electric current is there, for which physical unit is ampere. I'm representing with the capital A, we represent is the capital A. And similarly there are derived unit. Of course, for the derived physical quantities, like there are multiple, numerous number of the derived physical quantities. Famous of them I can give you, like the force. Like the force is a derived physical quantity, and the unit of force is Newton. We called it Newton. Okay, though Newton is the abbreviation, is the popular name for that unit, kg meter per second square. Okay, kg meter per second square. There are others as well. Acceleration meter per second square, as acceleration is also a derived physical quantity. Okay, pressure, popular one, pressure. For that the derived, for that the unit is Pascal. We represent the capital P. Okay, Pascal. It is actually Newton per meter square. Okay, and you can change the Newton as kg meter per second square. So this is the about the physical quantities and the units. Now let's jump into the main part.